and maybe work for weeks and disappear. And when he came out, he had some invention that was going to solve the crisis. And I just admired that. I thought, wow, I want to be one of those engineers that goes into the laboratory and builds something good for people. I enjoyed going down with my father and seeing where he worked and how he hooked circuits together and made diagrams on screens, and I sort of admired that. But my father never pushed myself or my siblings to be engineers. I was the only one that became an engineer like my father. It's a type of learning on your own when you build something that is much more important than learning from books. If you're building something for yourself, something you're going to use in your personal life, or maybe you're just modifying a car, whatever you're doing, it's going to be so perfect. In early age, I was able to come across transistors before almost any other kids could touch these magical parts that were parts of computers. And I learned that a transistor is a decision maker. It can decide yes or no, just like a remote control. Push a button and something happens. That's pretty much how a transistor works. I came across a journal by total accident. Almost everything good in my life that led up to Apple Computer was accident after accident after accident. Just discoveries of things that I found interesting in life. And I found a journal that described computers. And back in those days, you never thought you'd ever see a computer in your life. They were huge multi-million-dollar monstrosities that the government had and research had. You'd never really see one yourself. And in that manual, I discovered it taught the arithmetic of ones and zeros, binary, the language of computers, the logic of computers. Well, I took a bunch of transistors, and for an early science fair project when I was only 10 years old, on a big, huge piece of plywood, I nailed in nails as connectors and soldered transistors and diodes and resistors and made a huge, huge device for that young an age that would play tic-tac-toe and not lose. I didn't know that these little projects for school that I was working on, well, they were huge. They were like the equivalent of large engineering projects that much older people who worked as engineers for salaries in companies would do. I didn't know that. I just did it for fun. You know, there's different kinds of rewards in life, and computers became my internal reward. I was going to love and work towards computers and work towards designing them my entire life, even though I didn't think there were any jobs in computers. I felt that engineers designed things like televisions, radios, guidance systems for missiles, that sort of thing. I didn't think that engineers would design computers, or that I would ever get to work in computers, but I would do it as my fun hobby, as a pastime, as the thing that you'll do when nobody's paying you a cent to do it. One of my first programs was a chess problem. And it's a well-known chess problem called the Knight's Tour, where the knight has to hit every chair, every square on the chessboard exactly once, and nothing came out. The lights of the computer flashed a little, but nothing came out. I waited 5 minutes, 10 minutes, 15 minutes, 20 minutes, and nothing came out. Well, I went back and analyzed my program. I studied it a little bit further, did some printouts the next week, and I found out that my program was correct, but it would take 10 to the 25th years to solve, which is longer than the universe has been here. And what that means is that the power of a computer, how fast a computer is, raw power, doesn't lead to important answers to even some simple problems. Thinking out a clever and appropriate approach is still in the realm of human beings. It takes humans to solve the difficult problems, to come up with an approach that works well and works fast enough to solve. Engineering is all about efficiency. Efficiency is output divided by input. You want to get the most out for the least in. You want to use your energy or your parts or your resources very effectively. So I started trying to outdo myself and compete against myself in a game, redesign the same computer, but use fewer parts. And one of the strategies I came up with was, look at what's available, and if something does the job well, but it was designed to do something else, and it's one little part, almost all parts are the same price, In chips, almost every chip costs $1 to make. Use that chip for what you need it for to save parts, even though it was intended to do something else. I got very good. I developed excellent skills at designing computers. My computer designs were all on paper. I could never afford to buy even one single chip. So my designs, I noticed, were half as many chips as the companies that made these mini computers. Companies like Hewlett-Packard, Varian Corporation, Digital Equipment Corporation, Data General, and so on. I sat down one day, I closed my door, and I designed on paper the Data General Nova computer, and it took half as many chips as every other computer I had ever designed. Whoa, that was a shock. The architecture matched the components that you could build it out of. The architecture of the computer matched chips. It's like the architecture of a building matching the sorts of beams and lumber and metallic parts that you can buy. You can come up with a design that's much more efficient, many fewer parts for the same output. I was impressed. I told my father at that time that someday I was going to own a 4K Nova computer. The reason I chose 4K, that's the minimum amount of memory that could run a computer language, so I could type in programs to solve problems and play puzzles and play games. And my dad said, "How are you going to do that? The computer costs as much as a house." And I was stunned. So I said, "Well, I'll live in an apartment." So I drew a line in the sand. I decided one day in my life I was going to own a computer instead of having a house even. The next year, I was, like I said, this is a humble story. I wanted to go to work for a year to earn the money for my third year of college. I wanted to pay my way through college. And I accidentally walked in a door. They were building a brand new medium-sized computer. I applied for a job. I knew so much, I got the job. And I programmed a computer for a year. This is in between my second and third year of college. While I worked at that company, one of the executives heard that I used to design all of the mini computers from companies like Hewlett-Packard and Digital Equipment. And he said, "Did you ever build one?" And I said, "Oh, no, I could never afford a single chip." Well, he had connections to the chip industry in Silicon Valley, so he got me chips to build this computer that I designed. And it had a little front panel, it had a bunch of switches to dial in ones and zeros, and it had the button to push them into memory. And it was like computers that I had studied all my life. And I built this computer and built it with a friend. And the friend said, "You've got to meet this other guy who's like you, Steve Jobs. He went to our high school and he knows digital electronics." So Steve came over, and on the sidewalk we started describing the pranks we had played, the tricks we had played at school. And I had lots more than Steve, but he had some interesting ones. And then we talked about what we had done with chips. And Steve told me how he had built a device that counted frequencies, like the tone of a guitar string, and it would show it in a display. And I told him how I had designed all these computers. And then we talked about life, because we were both in our young 20s, and you're kind of seeking, the formulas, the philosophies, the religions of your life. And the counterculture was very strong in the San Francisco area back then. The 60s, the days of the hippies. And there was all this, I really admired this thinking, new thinking, saying we can live differently than people say life has to be. And I was always open to thoughts that were challenging the way things are today. But I wasn't going to become, one of those hippies and use drugs and fly away, but I still admired them as people. Steve was more a true counterculture child, counterculture soul. He hung around with other people who had no money and basically wanted to figure the way to get around the world and travel and do things everywhere with no money. He made money occasionally selling electronic parts in used parts stores. It was called surplus stores, and he knew, he had a real good knack for knowing if you could buy a switch for 6 cents and sell it to somebody for $60, they wouldn't know that you had gotten it for 6 cents. And I didn't like that very much. So I wasn't I wasn't as much of that way as Steve. I was pretty much feet on the ground, going to be an engineer, going to build things that do things for people. Really wanted to make my life that way. Steve read books about